How is lens adjusted? When the muscles are relaxed, the lens becomes thin. Thus, its focal length increases. This enables us to see distant objects clearly. When you are looking at objects closer to the eye, the ciliary muscles contract. This increases the curvature of the eye lens. The eye lens then becomes thicker. Consequently, the focal length of the eye lens decreases. This enables us to see nearby objects clearly. For near vision, the ciliary muscle contracts to release tension on lens, which relaxes into a thicker, more spherical shape to focus on nearer object. For far vision, the ciliary muscle relaxes to tighten and flatten the lens to focus on further objects.
High curvature of lens for near vision is required. Lesser curvature of lens is required for looking far object. For normal eye, when lens is thick, then we can see nearer object clearly but far off object appears blur. When lens is thin, then we can see far off object clearly but nearer object appears blur.
Why are we not able to see object closer than 25 centimeters? The focal length of the eye lens cannot be decreased below a certain minimum limit. Try to read a printed page by holding it very close to your eyes. You may see the image being blurred or feel strain in the eye. The minimum distance at which objects can be seen most distinctly, without strain, is called the least distance of distinct vision. It is also called the near point of the eye. For a young adult with normal vision, the near point is about 25 centimeters. The farthest point up to which the eye can see objects clearly is called the far point of the eye. It is infinity for a normal eye. Range of vision. Distance between near point and far point is called the range of vision. A normal eye can see objects clearly that are between 25 centimeters and infinity. The vision is blurred due to an inability of the rays of light to focus clearly on the retina. This is called visual defect and it occurs due to the refractive error of the eye. There are mainly three common refractive defects of vision. These are I. Myopia or near-sightedness or short-sightedness. 2. Hypermetropia or far-sightedness or long-sightedness. And 3. Presbyopia. Myopia near-sightedness. A person with myopia can see nearby objects clearly but cannot see distant objects distinctly. Characteristics of myopia defect are: the far point is nearer than infinity, may see clearly up to a distance of a few meters. In a myopic eye, the image of a distant object is formed in front of the retina and not at the retina itself. Cause of myopia. Myopia defect may arise due to I. Excessive curvature of the eye lens, or 2. Elongation of the eyeball. Correction of myopia. Myopia can be corrected by using a concave lens of suitable power. A concave lens of suitable power will bring the image back onto the retina and thus the defect is corrected. Now let us see near-sighted vision. In this case, the lens becomes thick, so a myopic person can see nearer object clearly. If the object is at far off place, then whether we try to focus nearby or far off, in both case image is formed before retina and appears blur. Using concave lens of suitable power, myopic vision or near-sighted vision can be corrected. Here is an example of myopic vision. For a student with normal vision in classroom can see both near by distance and far off distance clearly. But for student with myopic vision can see nearby placed object clearly, but board appears blur. As the problem increases, then slowly far points shift more and more closer. With increase in corrective power of concave lens, the original vision become more and more blur. Moderate and extreme case person can see only up to few centimeter. Here is another example of myopic vision with sport complex surrounding. Hypermetropia, farsightedness. A person with hypermetropia can see distant objects clearly, but cannot see nearby objects distinctly. Characteristics of hypermetropia defect are: the near point is farther away from the normal near point, 25 centimeters. Such a person has to keep a reading material much beyond 25 centimeters from the eye for comfortable reading. Light rays from a close-by object are focused at a point behind the retina. Cause of hypermetropia. Hypermetropia defect arises either because I. The focal length of the eye lens is too long, or 2. The eyeball has become too small. Correction of hypermetropia. This defect can be corrected by using a convex lens of appropriate power. Eyeglasses with converging lenses provide the additional focusing power required for forming the image on the retina. As understood, in case of far-sighted vision or hypermetropia, the lens become thin, so a person with far-sightedness can see far-off object clearly, but the nearby object appears blur. In either condition of focusing for far or near, for a nearby placed object, in case of far-sight vision, the image appears blur, as the image is formed behind the retina. Using convex lens of suitable power, far-sight vision or hypermetropia can be corrected. Here are the diagrams of myopia and hypermetropia.